Areas of triangles and the law of sines. So what's cool about the law of sines is you don't have to have a right triangle. Okay, first thing we're going to talk about is area of a triangle. A lot of you know area formula is half base times height. Well, if we have two sides and an angle, we can also find the area of a triangle using that. Okay, I want you to draw a triangle and label it A, B, C. Across from our angle A is lowercase side a. Across from our angle B is lowercase side b. And C and C are opposite each other as well. Okay. When it comes to our formulas, you'll notice we have a bunch of different formulas. Okay, let's go through the first one. It says if I take half of lowercase b, so side B, times side C, and take the sine of angle A, it'll give me my formula. Okay, I don't know if you guys remember geometry, but what we have is side, angle, side. Okay, I think that is a lot easier to remember than, oh, what side do I have, what angle do I have? Okay, the important part is that your angle is in between your two sides. Okay, if I have this angle over here and these two sides, it doesn't work. Your angle has to be in between your two sides, okay? Then really these don't matter. You just take half of your sides multiplied together and the sine of your angle. Okay, never take the sine of a side, always take the sine of an angle. Okay, kind of, sort of? Okay. Says problem 1, triangle has two sides, 12 and 15. Let's draw a triangle. Mine always end up being equilateral, I don't know why. And then label two sides, 12 and 15. Doesn't matter what two sides you label 12 and 15. Okay. It says the measure of the angle between the sides is 24 degrees. So wherever your sides are, in between them for an angle, we're going to mark our 24 degrees. Okay, are we good with the setup?
Yeah.
Okay, do I have side, angle, side?
Yes.
Yeah, so then my formula works. To find area, all I gotta do is take half times my sides. So what are my side lengths?
12 and 15.
12 and 15. And then times the sine of my angle. And my angle is 24. Okay. So half of our sides times the sine of our angle. All this can go straight into your calculator since it's multiplying. It says round to the nearest tenth. Put it in there and what do we get?
36.6.
Awesome. 36.6. Area needs a label. My sides are inches, so inches squared. Area is always squared. Okay. Questions, or that's the only example of that type? Questions? Okay. The next thing we got going on is our law of sines. How come I can't get this to, oh, that's why. Okay, same triangle where we have sides, angles ABC and the sides across from them are just lowercase. Okay, what the law of sines tells us is that the sine of our angle and the side opposite of it have to be proportional throughout our whole triangle. Okay, look at my angle A, this angle, and I take the sine of it and put it over my side A, it has to be proportional to my angle B sine and my side B, as well as angle C and side C. Okay? I think the important thing to remember here is that sine goes on top and your side goes on the bottom. That's probably the trickiest thing about the law of sines. Okay, let's do an example. It says I have triangle KLM. Let's draw a triangle and label it KLM. It says angle K is 120 degrees. Well, mine doesn't look like it, but it doesn't matter. It says angle M is 50. And then side ML is 35 yards. Good with the setup? Okay. The important part. Oh, and then I need to find KL, sorry. This is what I'm looking for, KL. If I look at my 120 degree angles, do I have the side across from that? Yeah, which one? 35. So those two are going to match up. My 50. Do I have a side across from it? No. Do I want it?
Yes.
Yeah.
Angle
Say that again, bud.
L is 10.
Yep. So like if I was asking for this side and I didn't have angle L, that'd be really helpful. That triangles that up to 180. Okay. So let's set up our proportions. Sine on top. My first fraction, I personal preference like to put the one that I know both things of. Doesn't matter where you put them in. So I'm going to take the sine of my 120 angle over, we said, what side matches up with it? 35. And that has to be equal or proportional to the sine of my other angle, which is 50, over the side across from it, which is x. Very good. Okay. Questions here? How do I solve this stuff? Remember how to solve proportions? Cross multiply. Here I get x sine of 120 equals here I get 35 sine of 50. On my left, how do I get x by itself? Good. Divide by the sine of 120. What I do over there, I have to do over here. You can put this all in your calculator. I personally would do 35 sine of 50, enter, and then divide by sine of 120, but if you use parentheses correctly, you can do it all at once. What did we get?
That's not great. I got 0.2.
No.
30.959.
So if I round to the nearest side, like yard, what do I get?
31.
31. 31 and I label yards. Are you in radians?
You have to flip the side of 125. Oh, I'm looking at 5. I was just deciding by 120.
Okay, you're good then? Okay, Triangle PQR. Draw triangle PQR and label PQR. Angle R is 97.5. Side R is 80. My side P is 75. And I'm looking for angle P. Do I have stuff that matches up?
Yes.
I sure do. Somebody give me my first fraction.
Sine of 97.5 over 80.
Good. Sine of 97.5 over 80. And what's my other one? Just x over 75? Sine of x over 75. Now what? Cross multiply. I get 80 sine x equals 75 times the sine of 97.5. Now what? Ooh, divided by what? 80. Okay. I still have the sine of x left, but I want you to figure out what this is first. Okay, so put 75 sine of 97.5 divided by 80 in your calculator. And what do we get? Give me 4 decimal places. I got 9295.
That's what I got.
Yeah, 9295. You might have just missed a number or something. Okay. How do I get rid of sine?
Divided.
Try to divide by sine? No. That doesn't make no sense. Sine with the negative one thing. Very good, Chloe. X is an angle. And remember, to find angles, we always use our inverse. Or the negative one thing, whatever you
That's
want to
technical
call it.
term.
The negative
The
one.
negative
technical
one
term.
thing.
So if I take the inverse sine of 0.9295, we should get 68.4 degrees. Yes?
Yep.
Questions? Do you like these?
Yeah, these
Yeah.
are more understandable.
It's
It is a lot easier because there's actually even for you to go to.
a lot easier because we don't have to talk.
Okay, word problems, everyone's favorite. Says a landscaper sights top of a tree at a 68-degree angle, then moves 70 feet away from the tree and sights the top of the top of the tree at a 43-degree angle. How tall is the tree? So, what I'm aiming for is to find how tall my tree is, right? Where does the 68-degree angle go? B, right here, 68 degrees. And I know that because then she steps away. Where's the 70 go?
Next is right.
AB, the side.
I didn't know.
And then the 43 goes angle A. Or actually, I'm going to squeeze mine in there. Yours is probably too small.
Wait, so there's
Oh, we
like
have a
two
little
triangles and one.
2 triangles and 1.
Oh,
Okay. My goal is the height, right?
Yeah.
What do I know in like the little triangle?
90 degrees.
90, what else? And the 68, do I know any sides?
Well, you can figure out this.
180 minus 68.
Give the other angle between on these sides.
Well, I'm the.
Okay, so the other triangle, I know this 43,
Yeah.
and we've been dealing with law of sines, which means I'm probably going to use law of sines.
That
So if I know this angle, that'll help me find what?
The middle side.
The middle side, this side. Let's call that side A. Okay. Well, I have to use the 70 somehow. If I'm using 70, what am I probably also going to find?
BOC.
the angle.
BC.
The angle across from 70. So up here. Okay. So my sides and angles across from each other. Let's work on finding this angle. Lots of geometry today. If this angle is 68, how can I find this angle right here?
Subtract it.
Good. 180 minus 68. How much is that angle? 112. So right in here we got 112 degrees. How does that help me find my blue angle?
Because you can
Add that.
68.
It has to equal 180.
Has to equal 180. So I got 180 minus our 112, this angle, minus our 43, and I get 25 degrees for my blue angle. Okay, so up here, I got this to be 25 degrees. Okay, now it looks pretty good. I got sides and angles across from each other. Okay, so let's set up our law of sines. Let's have the sine of 25. What matches on bottom? 70. What's my other one going to be?
A. Oh, sine of
Sine of
43 over A.
Good. Sine of 43 over A. Andrew, very common mistake to put the side next to the sine, but we fixed it. Good. Okay. Solving. How do I solve? Cross multiply. So I have A sine of 25 equals 70 sine of 43. It's a 7, sorry. Then what? Divided by sine of 25. Oh boy. And put all this into our calculator, and what do we get out? Give me 4 decimal places.
112.962.
Cam?
112.962.
4.
4.
4. Did you get that? Probably just punched it down. Okay. That is my blue side here. Okay, I'm going to redraw that triangle. My small one. Okay, so there's my right angle, here's my tree. And I know this angle is 68, and I know this side is 112.9622. And this is the side I'm looking for. Good news, I have a right angle. We love right angles. I like them too. SOHCAHTOA! How does x relate to 68?
Honestly, pretty into
Opposite adjacent hypotenuse.
Wait, what?
How does x relate to 68?
Opposite.
Sine, opposite, hypotenuse. We got the sine of 68 equals my opposite side, x, over my hypotenuse, 112.9622. How do I solve for x? Multiply it over X equals 112.9622 times the sine of 68. Multiply it over. Get x by itself. 7. Good. Label feet. This is a 1. Now it looks weird.
When did you decide to major in math?
Because I love it.
Do you really?
Yeah, why? Is that a bad thing?